welcome. In this lecture, we're going to talk about the vertical asymptotes. So now we're in the second category. So we're in this category here, right? So we're talking about, so you might not see it because it's written, it's kind of smaller. Well, all I did was added in this plus or minus. Remember, that just kind of means that we've got a circumstance where we've got, right? So this is like the x-axis, and we're looking at what happens to the outputs as we're approaching A from either, right? This would be the A from the right, like the right-hand limit towards A, or the left-hand limit towards A, and then we're going to look at what happens with the output. So let's go ahead and get started on that. Okay, so there's kind of two different circumstances. The first one, I'll draw here where we have, so this is my y-axis, and this is my x-axis. This is my x-axis, and I'm looking at the graph of the function. So I'm looking at y equals minus 1 over x minus 1. So if I draw that, then you can notice, again, you know where to look for an asymptote because you know on the bottom, right, at x equals 1, I'm getting, like, the bottom's going to 0, which means the top is getting, right, infinitely big. So I know that at x equals 1 is kind of the place that I'm going to be focusing in on. And the graph of the function actually does kind of, you can see, right here, as I approach from this side, I end up approaching kind of minus infinity because I'm going infinitely far down. And then as it approaches from this side, I'm going to get plus infinity, right, because it's going infinitely far up. And we often just write plus infinity as infinity. You can remember that. Okay, so I have on the top, right, so from the left-hand side, right, and then just to remind ourselves, this is approaching A, which is 1. So, and maybe I'll even just kind of, let's do this with the correct numbers. So this is approaching 1 from the left-hand side, and this is what I mean when I say approach 1 from the right-hand side. Okay, so you can see on this side, what we're looking at is an example of where I have the limit as x approaches A from the left-hand side. So A, and then we have this little minus side. Just say that we're coming from the left-hand side. The numbers don't have to be negative, but my inputs are less than that. Okay, so then I have f of x equals infinity. So this is what I'm looking at as an example on this side. And we do, in fact, have that. So what's going on here is that we have the limit as x approaches 1 from the left-hand side, right? As x approaches 1 from the left-hand side of our f of x here is minus 1 over x minus 1. Okay, and this is going to equal, right, this equals infinity because it goes up infinitely far. So this is an example of that. And on this side, we are looking at a circumstance where we go towards minus infinity as we come from the right-hand side, right? So this is an example on this side of where we have that the limit as x approaches A from the right-hand side of f of x is going to equal minus infinity. Okay, so we have that the limit as x approaches 1 from the right-hand side of, and this does look, like this looks like this circumstance here, of minus 1 over x minus 1, right? As we approach, as our input values approach from that side, we're going infinitely far down, okay? So this is going to equal minus infinity because we go infinitely far down. Okay. So these do kind of match up. So this is an example where you have the left-hand limit is infinity and the right-hand limit is minus infinity. And then we can swap it, right? If they were going in the same direction, then the limit would exist and we wouldn't have to do those two separately, right? So that's something kind of good to know. And now I'm going to erase this part right here to give us room. So now, so that's one circumstance we could look at. So here's the other circumstance that we could look at. So we're going to have, let me make my x-axis a little bit lower to give myself enough room on this side. Okay, so this is my x-axis and then my y-axis. I'm going to want it to be a little bit over here. So this is my y-axis. Okay, and then again, so I'm going to look at the function. So I'm going to look at the function here. I'm going to look at the function y equals, and I want it to be 1 over x plus 2. So let's go ahead and draw that. So it's going to go, if you look at it, you know that we're running into problems at minus 2, right? So we know that because that's when the bottom equals 0. So we know that that's actually going to give us our, so x equals minus 2 is our, so x equals 1, this is our vertical asymptote, right? So x equals minus 2 is a vertical asymptote here. We can already kind of tell without looking at the graph that we're going to get, that's where things are going to explode up because the bottom's going to 0. But let's look at the graph to figure out kind of the picture of what's happening here. This is a picture like this. Boom, boom, boom. Okay, so this is the graph of that function. And then you can see, so on this side, we're looking at what happens. So let's like observe a few things which are going on. We remember that, I can put some of these down, that approaching from this side is approaching minus 2 from the left-hand side. And approaching from this side is approaching minus 2 from the right-hand side. Okay, so this minus and this minus are both necessary. They're serving different purposes. Okay, and we have that. So on this side, we're looking at the limit. So this is a circumstance where we have that the limit as x approaches a from the left-hand side of f of x, so of f of x, this is going to equal minus infinity, right? This is going down to minus infinity. Okay, and you're going to see this one's going up towards, right, it's going infinitely far up, so this is going up towards positive infinity. So this on this side, we have an example where you can already see that this is an example where the limit as we approach from the right-hand side. So this is an example of the limit as, let's put down some of these so you don't drop them, x approaches, and then we're coming from the right-hand side, so I write an a plus here, of f of x. Well, we look, it goes infinitely far up. This is a plus infinity circumstance that we just kind of read like that. Okay, and then what does that mean in this particular circumstance, these two things? This is what's going on, right? Because if you look at it here, you can actually see this does exactly what we get, that we're taking the limit as x approaches minus 2 from the left-hand side of this function f of x, which is 1 over x plus 2, so of this. And we do indeed, this goes infinitely far down, we get minus infinity. So this is the circumstance of what's happening here. And over here, we do have here that the limit as x approaches, right? And we're taking minus 2 from the right-hand side. So this is minus 2 from the right-hand side of our function, which is 1 over x plus 2. And this is going to equal, it goes infinitely far up, this is going to equal infinity. Okay, so this does work out. So this is the circumstance where it's possible that you have to do your right hand and your left hand limits separately. Because in this one, the right hand, right, it goes infinitely far up, so our left hand limit is infinity. This one goes infinitely far down as we approach from the right, so our right hand limit is minus infinity. And this one, if I'm approaching from the left, right, I go infinitely far down, so I get minus infinity. And if I'm approaching from the right, I go infinitely far up, so I get plus infinity, okay? So, hope that made some sense, and I will see you in the next lecture.